In this video, we're going to solve some exponential expressions by finding the same base on both sides of the equation. As we do this, we will also employ some exponent properties that allow us to get the same base. First, we're going to solve 27 to the 3x plus 5 equals 81 to the 4x plus 1. Right now, we don't have the same base, so we're going to factor 27 and 81 and see if they give us the same base. 27 is divisible by 3 9 times, which is divisible by 3 3 times, which is divisible by 3 once. So 27, I'm going to put it in parentheses with the exponent on the outside. 27 is 3 to the third power, and we have 3x plus 5 outside of it. Equals 81. Well, let's factor 81. 81 is divisible by 3 27 times, which is divisible by 3 9 times, which is divisible by 3 3 times, which is divisible by 3 once. We've got 3 to the fourth power. Replacing the 81 with the 4x plus 1 outside of the parentheses. Now we can use an exponent property to combine our exponents together. You may recall when we're going through parentheses, we have to multiply those exponents. Be careful as we do. We want to multiply the 3 by both terms. So we have 3 to the 9x plus 15 equals, multiply the 4 by both terms, 3 to the 16x plus 4. When we do this, you notice we have the same base on both sides. So the exponents must also be equal. 9x plus 15 must equal 16x plus 4. We can solve by moving the exponents to one side. Moving the x's to one side. Subtracting 9x gives us 15 equals 5x plus 4. Wait a minute, 16 minus 9 is, subtracted 11. 7x plus 4. Then we subtract 4 from both sides, giving us 11 equals 7x. Divide both sides by 7, and x is equal to the fraction 11 sevenths. We found that by getting the same base on both sides, factoring 27 and 81, using our exponent properties to multiply the exponents, and if we have the same base, the exponents must be equal. Let's try another one. How about 1/9 to the 2x equals 3 to the 7x minus 1? In this one, the 1/9 becomes interesting because the 1/9 is a fraction. What type of exponents make fractions? Negative exponents. You might recognize that 9 is divisible by 3 twice. 9 is 3 squared. However, to create the fraction, the exponent must be negative. A negative exponent creates the fraction. We still have 2x outside and 3, which is already primed, to the 7x minus 1. And now we can multiply our exponents, giving us 3 to the negative 4x equals 3 to the 7x minus 1. And again, we find ourselves with the same base on both sides. Same base means the exponents must be equal, so we have negative 4x equals 7x minus 1. An equation we can quickly solve by subtracting 7x from both sides, giving us negative 11x equals negative 1, and dividing by negative 11. Negative divided by negative is a positive. X is 1 over 11. We found that by writing both sides with the same base. 9 was 3 squared. The fraction, however, we can create with a negative exponent. Negative exponents create fractions. Now that the bases are the same, we can say the exponents also must be the same.